Welcome! I am Teacher M. This math tutorial video is focused on limit properties. If you are interested to learn more about this topic, stay and watch the entire video. In this limit properties video series, 8 limit properties will be covered for the entire series. These are constant, identity, scalar, sum and difference, product, quotient, power, and radical property of limit. For the 7th episode, the video is focused on power property. Before you continue to watch this video, it is advisable to learn first the following properties: constant, identity, scalar, sum and difference, product, and quotient property. Power property states that the limit of a function raised by nth power is the nth power of the limit of the function, where b and c are real numbers, n be a positive integer, and f and g be functions with the limits l and m. To explain it better, let's solve this example. What's the limit of x raised by a second power as x approaches 1? Observe that the function is raised by a second power. Apply first the power property. By applying power property, the limit of x as x approaches 1 is being raised by a second power. This is the meaning of power property. You can take the limit of the function that is being raised by a power before you perform the power. In this case, the limit of x is taken first before squaring it. To solve this entirely, apply the other properties of limit. The limit of x as x approaches 1 is 1 by applying the identity property. Then simplify. Square of 1 is 1. We can conclude that the limit of the function as x approaches 1 is 1. To make it clearer, what is the limit of the cube of the sum of x and 1 as x approaches negative 2? I'll give you 5 seconds to decide whether to pause this video and give it a try or continue watching the video. Let's proceed. This will be the cube of the limit of the sum of x and 1 as x approaches negative 2 by applying the power property. Similar to the first example, we can take the limit of the function that is being raised by a power. In this example, the function is being raised is the sum of x and 1. Take the limit of it before getting its cube. To continue, apply the limit property that is applicable. We can now take the sum of the limit of x as x approaches negative 2 and the limit of 1 as x approaches negative 2 by applying the sum and difference property. Of course, the whole limit is still being cubed. The limit of x as x approaches to negative 2 is negative 2 by identity property is added to the limit of 1 as x approaches negative 2 is 1 by constant property. Don't forget the power. Simplify. The sum of negative 2 and 1 is negative 1. Lastly, cube of negative 1 is negative 1. Thus, the limit of a cube of the sum of x and 1 as x approaches negative 2 is negative 1. Let's have a little harder example. What's the limit of the square of the quotient of the sum of 2x and 3 and 4x as x approaches 1/2? I'll give you 5 seconds to think whether to pause this video to give it a try or continue watching the video. To continue, we have the square of the limit of the quotient of the sum of 2x and 3 and 4x as x approaches 1/2. The same process is applied like on the previous examples. Take the limit of function that is being squared, which is the entire sum of 2x and 3 over 4x before applying the power. Next, copy the power, and we have the limit of the numerator, which is the limit of the sum of 2x and 3 as x approaches 1/2, and the limit of the denominator, which is the limit of 4x as x approaches 1/2, by applying the quotient property. Rewrite the power in numerator by applying the sum and difference property. We have the sum of the limit of 2x as x approaches 1/2 and the limit of 3 as x approaches 1/2 over the denominator, which is the limit of 4x as x approaches 1/2. Rewrite again the power. In numerator, we have 2 multiplied to the limit of x as x approaches 1/2 by scalar property that is added to the limit of 3 as x approaches 1/2. Similar property will be applied in the denominator. 4 multiplied to the limit of x as x approaches 1/2 by scalar property. Still rewrite the power. Focus on the numerator. The product of 2 and the limit of x as x approaches 1/2 is 1/2 by identity property. And it is added to the limit of 3 as x approaches 1/2 is 3 by constant property. Over the product of 4 and the limit of x as x approaches 1/2 is 1/2 by identity property. Simplify the expression inside of the parentheses. The product of 2 and 1/2 is 1 and added to 3 over the product of 4 and 1/2 is 2. The sum of 1 and 3 is 4 over 2. Get the quotient of 4 and 2, which is 2. Finally, perform the power. Thus, the limit of the given function as x approaches 1/2 is 4. This is how to apply the power property and other properties such as constant, identity, scalar, sum and difference, product, and quotient properties of limit to find the limit of a function. To learn more on the remaining properties, you are warmly welcome to watch the other videos. If you learned on this video, hit the like button and subscribe to be updated and notified for other math lessons. See you!